Welcome once again to Architectural Engineering Student. And what we have here this day is preliminary speculative building design. We're talking about a shipping container. And we want to talk about this day when one might think that a shipping container is actually applicable to a particular site based on what's said to be the response spectral curve that might occur based on the stiffness of the shipping container and what's said to be the site soil natural period. And what we've got here is a theory development for shipping container. We consider the vertical perimeter, and some people might say this is the end of the shipping container. We turn this around this way, then this section becomes like the length section of the shipping container. We take a portion of the section that we're interested in, we load it with whatever condition we have or deformation, then we can find the particular condition, the natural period that occur for that particular section and element. So we talk about what do we need to do that. Well, one thing we need to know is the moment of inertia of that section. And so very simply, what we have here is the depth of the section. Here's one flange, here's another flange, and this is half the breadth, this is half the breadth, and then this portion right here is 1/2 the breadth of this flange, and this flange added 1/2 and 1/2 is equal to this 1/2 plus that 1/2 in the length of the flange that occur. Now there's a separate, due to the condition what's said to be the symmetry, there's a distance here then to the neutral axis, and that occurs at 1/2 the thickness minus what's said to be the, in the simplified theory, the thickness of the flange. And so D is said to be the distance from flange to neutral axis, and that's the center line to the center line. And then the flange, it has a particular thickness, T sub f, and T sub f is the flange thickness. And we go down here that by previous discussion, one can realize to their calculate condition that the moment of inertia I is equal to 2a sub f, as that is the area, 2 times the area of the flange, times the distance from the center line of the flange to the neutral axis. And that's said to be normalcy, and you can see volume 49 for that condition, where I is the bending moment of inertia of the vertical perimeter section. A is the area of the flange, and that's equal to TF times B sub F. That's the thickness of the flange times the breadth of the flange. And then the distance D is equal to the thickness of the total section T minus T sub F. That's 1/2 T sub F plus 1/2 T sub F equaling T, and then divided by 2. So then we, through substitution, we have what's said to be I is equal to T sub F B sub F times the quantity T minus T sub F divided by 2, and then I equals T sub F B sub F multiplied by T minus T sub F. The 2's cancel out there. We have I then is equal to T sub F multiplied by the quantity B sub F minus T, and that's the strange, unusual equation by substitution that either someone has or has not seen before. So then we go to what's said to be the ongoing condition in 3 development. E is said to be the modular elasticity of the section, and that's always steel in a shipping container. And then here's our model that occur. We have a load at the top, and that's caused by what's said to be the weight of the roof as a deformation occur, and that's related to the condition which would be the delta lateral soil displacement multiplied by the stiffness of the entire element. The element that we're interested in is this little cantilever here, and based on the quality and simplified theory, when we say that right angles remain right angles, then that little cantilever occurs at h, which is the height of the entire shipping container, divided by 2. And p to that particular cantilever is just 1/2 the p total, acting at 1/2 the height there, because that's where the inflection point occurs, creating the symmetry in the element for our simplified model theory. And so we have x equals kx, p equals the delta sublateral, and k is the stiffness of the system, where p is equal to the ground acceleration in minimum design criteria. There are other criteria, but that's the minimum. And then so we have delta limit based on some criteria that someone might have is equal to p times L cubed over 3EI, and then p then is equal to the delta lateral. A sub A is equal to p, delta lateral is equal to, in this particular instance, by the criteria, 0.001 h over 2, and that's by previous discussion. So then I required then is equal to a sub A times h over 2 cubed divided by 3 times 0.001 h over 2 times e, and then the I required then is a sub A times h over 2 squared divided by 3 times 0.001 e, where h is in inches. And then the I section, less than, greater than, equal to I required, yes or no. If yes, okay. If no, the section is no applicable in the region. The I section, okay. If yes, then continue. T sub n is equal to 2 pi times the square root of m over k, where k is equal to p divided by delta L, and m is equal to w over g. Then we get to the other portion here in our theory development. Is T sub n less than T truncated? If no, then the section is no applicable for the region. If yes, okay. And so what we have is our response spectral curve. Here's the truncated section. And if T sub n is in here, then it's a non-applicable solution. There is no solution for that truncated portion. If it's outside that portion, possibility 1, it's less than truncated T sub n. Possibility 2, it's larger than the truncated T sub n. Then that's in the response spectral curve. And you can see volume 49 for that discussion about response spectral curve. Then there's said to be a solution, T sub n, A sub A combination in the graph there, less than truncated portion, response spectral curve, so section is applicable, is an application okay in the region. Possibility 2 being T sub n, A sub A greater than the truncated portion, and that is also then application okay in the region. Other consideration, check for overturning by jurisdictional requirement, and also the base shear that occur for the particular element, known to be a statement in simplified theory, a length and unit length, whatever it happens to be, for the so-called condition in the symmetric section of the vertical perimeter, and that's the condition in finding that based on the theory development that we have. So in that condition, is theory development the true condition that people no ever are going to contest? We don't say that. Was all the calculate done right according to algebraic rule? We don't know. This is the original statement in the theory development, but it is said to be acceptable to present such a condition to other people so that they can look at it and decide for themselves in their discernment whether that makes sense to them or it does not. And that's this time in registered resident, no, wait a minute, that's this time in architectural engineering student.